Greetings, students. This is Mr. Torgerson. Today we're going to discuss practice test 4-4. Question 1. Determine if AB is tangent to the circle. This is a Pythagorean theorem question. So I will take, and I'll label this as a 4 because the radius is 4. I'll take a 4 squared, I will add 8 squared, and I will see if it is equivalent in value to 10 squared. 4 plus 6, the entire length here, is 10. So 16 and 64 compared with 100. Well, 16 and 64 is 80, and that is less than 100. This triangle is obtuse. This triangle here is obtuse. Question 2. Same question, but the opposite manner. Here I'm asking you for the side, and I'm telling you it is tangent. So this length here squared, x squared, plus 12 squared will equal 15 squared. So x squared plus 144 is equivalent in value to 169. X squared is equivalent in value to 25. Therefore, x is 5. All right, so tangent lines are always perpendicular to the circle where they intersect the circle at. So these angles are 90 degrees. And when I'm asking these questions, you're either doing a Pythagorean theorem and verifying if it's 90. So this one's not because it's less than. It's an obtuse triangle. Or you're doing the Pythagorean theorem and finding the missing side by either adding or subtracting. So again, here I subtracted because I was looking for a leg of the right triangle. Whereas as if I was looking for the hypotenuse here, if I had this 15 and I was looking for this 15, I would be adding. All right, question 3. Find the perimeter. So 3 of the sides are labeled, so I can take those 3 sides and add them together. 12.5, 17.6, and 17. One of the sides is not labeled entirely. So the 7 here is a partial length. It's not the length, it's not the entire length. So I will add the 7, but there's something else that needs to be added, and I need to figure out what that number is. So to find that number, again, these lines are all tangents. So I'm going to label these small sides as I go through. So because this is 7, this length is also 7. And 7 from 17 is 10. Because this is 10, this length is also 10. And 10 from 17.17 and 6/10 is 7 and 6/10. Because this is 7 and 6/10, this is 7 and 6/10 as well. And then here's the missing side length. 12.5, 12.5 minus 7 and 6/10 is 4 and 9/10. So the side length that I'm missing is 4 and 9/10. So I'll add 4 and 9/10 here to get the entire perimeter, which is 59 in value. You may have to spend some time using the calculator to evaluate this. Subtraction, some of these, they can be a little bit lengthy. Question 4. Tangent lines are equivalent in value if they intersect at a point. So these two tangent lines to the circle intersect at the point here. Therefore, they will be equivalent in value. So I'll take 4x minus 2 is equal to 3x plus 4. 3x from 4x is x. And 2 added to 4 is 6. And x is equal to value to 6. Next question. Find the length of each segment. So this is it's a radius or a diameter, this segment here, because it's from edge to edge on the circle. And this is a chord. Anytime a diameter or a radius intersects a chord at 90 degrees, it intersects it at equivalent values. So x is equivalent in value here to 18 because this angle is 90, and because this is the diameter of the circle. Next question is kind of a little bit misleading because I got the x here in the middle of the circle. That means I'm asking for the diameter, the entire length. If I have it on one side of the circle, it means I'm asking for the radius. So here I am asking you to find the diameter of this circle. So the radius here is the length from here to the edge, 7.2 and 7.2 added together. So my radius is 7.7 2/10 plus 7 2/10. So in other words, my radius is 14 4/10. And my diameter is twice the radius. So x is equal to 28 8/10. If you have any issues understanding what it's asking on this question, just ask me during the test and I'll tell you if it's the diameter I'm asking for or the radius. It is a diameter when it's in the middle here on this computer program. And it is a diameter when it's in the middle here and it's not on one side or the other of the circle. All right, so give me a minute and I'll go through question 7. Okay, we're back with question 7. So this one here is a Pythagorean theorem question. So this 8.6 is a radius on this circle, meaning that it will be the same as this 8.6 here. They'll be the same. So I will do x squared plus 8 6/10 squared is equal to 9 5/10 squared. So if I square 8.6, I get about 73 at 96/100. If I square 9.5, I get 90 1/4. When I take the difference of these, or subtract them, I get about 16 and 29/100 to be exact. And the square root of 16.29 is about 4. So that is a Pythagorean theorem question. A squared plus b squared equals c squared. Next one is also a Pythagorean theorem question, but I'm asking for the hypotenuse of the right triangle. So this one's located on the longest side of the right triangle, whereas this one is on one of the legs of the right triangle. So here I will take 7 4/10 squared. I'll add 12 9/10 squared, and that will be equivalent in value to x squared. So 7.4 squared and 12.9 squared, when they add together, they make approximately 221 1700. And then when I square root that number, I get about 14.9, about 15 when it rounds. So that's really close to 225. Anyway, so those are Pythagorean theorem questions. We have right triangles within the circles there. Is how I can verify those Pythagorean theorem questions. All right, next groups. These are inscribed angles. So the inscribed angle is half the corresponding arc. So arc XWV, this arc along the outside of the circle here, outside of the circle, along the perimeter of the circle, XWV, here it is in blue, is double in value to the corresponding interior inscribed angle, not interior inscribed angle. So this will be 2 times 100, 200 degrees. Now again, this can be labeled backwards. If I label the arc and ask you for the inscribed angle, well then you're going to cut it in half, and that's coming up on the next group of questions. But question 10. So this angle here is 53. The question mark here is corresponding to the arc ML. So I'm asking you, what is arc ML? Well, it is double in value to that 53 once again. So these are the same question, they're just labeled differently. Here I've got a question mark here on the arc that I'm asking for. Here I'm asking you for arc with the letter name. All right, question 11. Here I've given you the arc, and I'm asking you for the inscribed angle, which is half of the corresponding arc. So I'll take 178 and I'll divide it in half to get 89 here, which is my corresponding arc. Of course, the inscribed angle is half of the corresponding arc, or the arc is twice the inscribed angle. All right, here, because I'm asking you for the question mark and it corresponds to the sum of these two, I'm going to add arc GF and arc FE before I divide it in half, or I can take half of each one and add it together. So I'm going to take 76 and 1/30 here, and then cut that in half. So that's half of 206, which is 103 degrees. All right, question 13 and 14. These are still inscribed angles, so I'm still going to do the same type of concept here. The inscribed angle is half of the corresponding arc, where the arc is twice the corresponding inscribed angle here. So I've got two options here with this setup here on question 13. I can either double the 93, because then if I double the 93, it's equal to the 13x minus 9, or I can take the 13x minus 9 divided by 2. Because 13 and 9 don't divide evenly by 2, it's preferable here to double the 93. So I'll set 13x minus 9 equal to 93 doubled. In other words, 186. So 13x minus 9 is equal to 186. Adding 9 to 186 yields 195. And dividing by 13 yields x equals 15. I can verify my work here by typing that 15 back in for x. So I can take 13 times 15 minus 9, and that will equal 186. All right, next item. These two inscribed angles are supplementary. They make the entire circle. So arc YW, YCW, and arc YXW are going to add to 360, meaning these two inscribed angles are going to add to 180, half of 360. So I'll take 26x minus 3 and I'll add that to 19x plus 3. Well, the plus and the minus 3x, it cancels out. So that when I add that together, it just makes 45x. And it will be equivalent value to 180. And dividing by 45 yields x equals 4. So these are not equivalent inscribed angles. They would be equivalent if they were corresponding to a diameter on the circle. But YW is a chord on the circle only. It's not a diameter. So that's why I did not set these equal in value. They are, however, supplementary in value because they correspond to the entire arc on the circle, the entire 360 degrees of the circle. All right, give me a minute here and we'll set up question 15. Okay, and we're back. So here I have a similar concept to the inscribed angle. This is a tangent line with a chord, or a tangent line with a secant line on a circle. So this angle here, angle B, will be half of the corresponding arc, 170 cut in half. This is a very similar concept to the inscribed angle concept we just talked about on the last set of questions. And again, it's half because this entire line would be 180. So if I was to take the angle of this entire line, it makes 180, but the circle is 360. So as I do each angle, it's half of the corresponding arc on the circle. Next question here. The inside angle here is the average of the two arcs. So these are two chords. And if this was through the middle of the circle, if they were diameters, the inside angles would be the same as the arcs. But here, because it's chords, the inside angles are the average of the two arcs. So I'm going to take 60 plus x, this is Ix, divided by 2, and that will be equivalent in value to 85 degrees. So I'll double the 85 here. That will yield 170. And then when I subtract 170 and 60, I get 110 degrees. All right, moving along. Next question here. This is a similar picture to this one above it. However, it's a secant line with a tangent line, and it's labeled slightly differently with the point outside of the circle. So what I have to do here is actually subtract 152 minus this value here, x divided by 2 will be equivalent value to 48. 152 minus x will be equal to 96. And then 96 subtracting 152 is negative 56. So x is equivalent value to 56 degrees. All right, so this next question, I changed it slightly because the variation of the question I intend to test you on is this one, not the one that was on the original practice. So I will go through the work on the original practice one here, for those of you that need to see it. But this is the one that's going to be on our test. So, and this is the one that was in the book as well, the one that we practiced. So RP is 105. What I need to do first is find the other arc here from R to P, the major arc. So I'll do 360 minus 105 to start this question, which that is equal to 155. So this major arc, 255. This major arc is 255. And then to get this question mark, we're going to subtract those and divide by 2. So we take this major arc and the minor arc and divide it by 2 to get the question mark, this angle that we're looking for here. So 255 minus 105 divided by 2. So a half of 150 is 75. Again, this is the variation that we intend to test you on, the type that we practiced in the book. Now the variation that was on the original practice, I'll go through it here with you now. To do it requires a little more effort. So here is my work for that. So I'm going to label this angle as x and this angle as y. I don't know x or y here. And the reason I'm labeling both of these is because they're supposed to subtract and divide by 2 to make 70. So I took y minus x divided by 2 equal to 70. I doubled the 70 to make 140. And then here's the thing you need to do. You need to replace y with its corresponding value in terms of x. So y is equal to 360 minus x. So that's where this 360 minus x came from. Y is equivalent value to 360 minus x. Combining the x's together makes minus 2x. 360 from 140 is negative 220. So the value of this arc here is 110 degrees. Again, this is slightly a backwards question. I intend to label the angle here inside, like it was in the book. And you'll subtract from 360 to get this angle, and divide by 2 to get this angle outside. Although this is an appropriate question that may perhaps come up on a future exam. All right, question 19. Chords on a circle. So the product of the chords, sorry, light turned off on me. The product of the chords is equivalent on any circle. So I'll take x times 9, and that will be equivalent in value to 18 times 8. Well, 9 goes into 18 twice, so I can just do 2 times 16 here to get the value of x. So I could do 9x equals 18 times 9 anyways. So x is equal to 16. Same deal here. X times 18 is equal to 27 times 14. Numbers are slightly larger on this question, but it's the same type of work. So I will take 27 times 14, and I'll divide by 18 to get that value. 27 times 14 divided by 18. Something like that on the calculator. Or I could do it by hand by dividing by 9 here, dividing by 2 on the 14. So dividing by 9 would be 3, and dividing by 2 into 14 would be 2. So that'd be 7. 3 times 7, 21. All right, next question. Secant lines and tangent lines. So here, the length 4, so the outside length on the circle, 4 times the entire length of the secant is going to be equivalent for both of these. So 4 times x plus 4 is equal to 3 times 5 plus 3. So the concept here is the outside length times the entire length are equal for any two segments that intersect outside a circle. So this is 4x plus 16. I could also take and divide both sides by 4 here, but either way is appropriate. This is 3 times 8. This is 24. 16 from 24 is 8. So x is 2. Same deal here, except I don't have an inside length on this one, on the 30. But the outside length times the entire length is still equivalent for these segments. So the outside length here is 18. The entire length is x plus 18. The outside length here is 30, and so is the entire length, 30 times 30. The outside length times the entire length are equivalent on any secant or tangent lines that intersect at a point outside the circle. Anyways, so it may be useful here to divide the 18 into the 900 rather than distribute it, but it's not required. So I did decide to do that rather than distribute the 18 into the 18 when I was working the question myself, but most likely you guys and girls are going to take the 18 times the 18 and get 324. So you're going to say 18x plus 324 equals 900. And you're going to take 900 minus 324, and you're going to get 576. And you're going to divide that number by 18 again to get the proper answer of 32. Give me a minute, we'll start the next set of questions. Okay, and we're back with the last set of questions here. So the last set of questions here is about the equation of a circle. X minus h squared plus y minus k squared equals r squared. So h is this value of x here. R is this value of y. Excuse me. K is this value of y. And r is the radius. So this will be x minus negative 12 squared, which becomes x plus 12. Minus a negative becomes a plus. This will be y minus negative 16 squared. So that becomes y plus 16 squared. And this will be 1 squared. I really don't care if you make that 1 squared into a 1 or just leave it as 1 squared, since the equation of a circle has the radius squared in it. Alright, next one, same deal. So h is 15, so this will be x minus 15 squared. K is 12 plus y minus 12 squared. I haven't given you a radius here, so I'm asking you to find the radius. In order to find the radius, you're going to need to do the Pythagorean theorem. Or you're going to need to do the difference between the points, in other words, the length between the center and the point on the circle is the radius. So r squared will be equal to, in value, the difference in the x's squared, 17 minus 15 squared, plus the difference in the y squared. In other words, how far are the x's apart, how far are the y's apart, squared. So this is going to be 2 squared. This is also going to be 2 squared, which ends up being 8. So this number here at the end is an 8. R squared is 8. You don't have to square root this. I'm not asking for what r is. I'm asking for what r squared is. So there is no need to square root that, because I'm not asking you for the radius. I'm asking you for the radius squared in the equation. All right, next one. Same question, it's just drawn instead of given to you. So the center here, the middle of the circle, is located right at this coordinate, which is at the point 3, 2. And the radius, well, the radius is, it goes right 3, up 3, left 3, and down 3. So the radius is 3 in value. So my equation here is x minus 3 squared plus y minus 2 squared is equal to 3 squared. And again, you can make that 3 squared into a 9 if you want. Make that 3 squared into a 9 if you want, but I'm not going to require it. X minus h squared plus y minus k squared equals r squared. H, k, and r. Very similar to the parabola form. Very similar to the point slope form of the line as well. Where you do point slope form, it's y minus y1 equals m times the quantity x minus x1. Question 26. The center here, again, is h and k, but these are plus 1 and plus 2, so it's actually minus 1 and minus 2. Again, very similar to the point slope form of a line where it's opposite. So my center is located at -1 and -2. And here I am asking you for the radius. So the radius squared is 9, meaning that I square root both sides. The radius is 3. So we go up 3, right 3, down 3, and left 3 from my center on my circle. And then connect the points together to make my circle. Now again, with this r squared equal to 9, technically I could have a -3 as an answer if this was not a length. So next year in Algebra 2, when they talk about this r squared with x squared being 9, having two answers, 3 and -3, that's what it's saying. There are two answers here, but length can never be negative. So the reason this r is +3 is because a length is always positive. That's why we only use the positive in the geometry class here this year. Anyways, hopefully this helps. Good luck on your test.